Sad.
The actor I don't care about in those movies that were terrible. Yeah, I heard about it. All right, let's clap for Ashley again.
Have you guys ever thought about something important in life, whether maybe academic, family, friends, or just personal growth in life? But there's one thing we always tend to forget. It's the one thing that drives us every day, and it's the crown jewel of our body, and it's also known as the brain. The brain is an amazing organ, the incredible control center for all the body's functions. It's the seat of intelligence, interpreter of senses, initiator of body movement, and control, with a future so vast. According to the 2013 article on National Geographic, making sense of the brain's mind-boggling complexity is a hard one. Our big brains are what has given us an evolutionary advantage. So today, I'll be going over the history of the brain, how the brain works, and the future of the brain. According to an article 2013 on charge.org.uk, our brains hold 100 billions of neurons. And able to see this in a bigger picture, we can take, for example, the Amazon forest. It's 2,700,000 square feet, and it contains 1 billion trees. So if our brain was mapped out like this, you can see how big neurons are in our brain and how big the forest is in Amazon. You can see and compare the pictures. So there is no ancient brain to weigh on scale, but according to July 18, 2013 on Scientific America, looking at earlier skulls gives us evidence about the volume of brains before and how they evolved over time. Early humans faced environmental challenges and involved smaller and more complex brains. The first 2/3 of history, the size was similar to an ape, being at the size of 550 millimeters, which was our brain earlier, and versus the apes of 400 millimeters. During this time, the brain showed subtle changes in structure and shape, and the brain only saw visual context through this. On July 18, 2013, article on Scientific America, reorganizing its functions away from visual towards parts of the brain. Now we can move on to the third evolution. We saw all actions in the brain mainly. It moved on from just being visual to being emphasis on language to the frontal lobe. And the brain size did expand over time. And now we can see that they realized that there was a relationship with planning, communication, and problem solving with the brain. And the brains grew to accommodate linguistic complexity, climate, dietary needs, and technological processes. And this graph shows the top of the climate as it increased, and then the brain also increased in size. So now that you know the history of the brain and how it evolved, I'll be now going on to the foregoing parts of the brain and telling you how it affects us and how it functions. The four ones are cerebrum, cerebellum, brainstem, and the pituitary gland. The cerebrum is the big guy, like Santa Claus. It's 85% of the brain's weight. It's divided into two hemispheres. And according to a 2013 article on acquired brain injury, it's responsible for thinking and has for voluntary muscles such as moving your hands and walking. The divided two hemispheres, according to Ned Herman of Science Alive, it is more future-oriented and more open for change. So it's basically used for your imagination and creativity versus your left brain, which is used for your logic, math, and language. The second one I'm going to show you about is the cerebellum. According to voluntary movements, according to an article on October 11, 2013 of Neuroscience, the cerebellum is approximately 10% of the brain's volume. We're able to walk correctly to modulate commands to motor neurons. This coordinates timing and force of muscles to produce body movements such as running, hugging, or twerking like Miley Cyrus badly. The small but mighty brainstem is the next one. It's small but mighty, but it controls vital functions. What it does is that it keeps us alive without us knowing, like magic. So examples would be breathing, digesting food, and circulation of blood. It operates involuntary muscles like the heart and the stomach. An example would be last Thursday when all of you guys were at Thanksgiving. The reason why all that huge meal that you guys taken was is able to move down the digestion is because of the brainstem, which is an involuntary movement. Next is the pituitary gland. Don't be fooled by its size, but it's the size of a pea, and according to an article of 2013 of Pituitary Society, it is very important. It takes messages from the brain and uses the messages to produce hormones that affect our bodies, such as growth, puberty, and metabolism growth. So now that you know the history about the brain and how certain aspects function, we'll now look into the future. Brain-to-brain communication. Burgess Rao and Andrei Stoko succeeded in human brain-to-brain interference with helmets that they use in computers. Here we have an example at University of Washington. They sat across from each other while they were playing a video game. And what he did is that he thought simultaneously, he thought in his head that when he will hit the space button, and that space button initiated in his brain to Andrea through the computer. The reason being is because the magnetic stimulation allowed for Stoko's cerebral cortex to involuntarily touch the spacebar on the computer from his thinking process. So, with that, we can change the way we share ideas and brainstorm and understand the world through the scientific of the future of the brain. So today I went over the history of the brain, how it functions and how it works, and third, the future of it. So hopefully you guys find it as amazing as I do.